Alright guys, so my live stream disappeared, which is always fun. So I'm re-recording this right now and I have to do it from my cell phone, so bear with me. But we're going to go through Unit 2, the big important stuff. And if you have questions as you're studying, just shoot me a message on Remind. So here's the three first most important things I want you to know. Number one, you have learning targets, right? So on your unit overview, you have I can statements, right, on your learning targets, and use those to study. Like, those are there for you. Those are there for you to check off as you go and make sure you can do those things. Number two, you can skip systems as you're studying. That's topic 7 on your review sheet, and you can skip it because no other classes are testing on it before break, so I'm going to wait to test it till after. And the last thing I want to remind you guys is, like, you got this. Like, don't forget that what we did in class was tricky. It was meant to be challenging, and you guys did a great job on it. So don't let yourself get overwhelmed about the fact that, like, doing that error analysis was tricky. That's how your brain grows, right? The messy stuff is where you grow. So don't get overwhelmed by that. You're gonna do great. Just send me questions as you study. So the first page of your review sheet goes through factoring and then solving by factoring. And the big thing I want to point out is the difference. So when you factor, you're just factoring, right? You're just getting it into a different form. When you solve by factoring, you're going to actually get an equation or an answer like x equals a number. And so when I solve by factoring, I need to factor anyway, so I'm just going to do those. So I'm going to start actually with letter C. So let's look at this one. I have x squared minus 121 equals 0. So starting there, I see that these are both perfect squares. So I'm going to set up my two sets of parentheses. I've got x minus 11 and x plus 11 because x times x would give you x squared, and 11 times 11 is 121. And then to solve that, you're going to set each of those equal to 0. So x minus 11 is 0, x plus 11 equals 0. So I would get x equals 11 and x equals negative 11. And so remember, if you were factoring, you would stop on this step, but solving by factoring, you need to go through and actually get your solutions. Let's go to another one. So let's say I'm factoring letter A. So this one, I've got 4 terms. There's nothing I can combine. So I'm going to factor by grouping. So group my first 2, group my second 2. The GCF of the first 2 is x, and that leaves me with x minus 1. The GCF of the second 2, and that's actually a typo, is negative 9, and that leaves me with x minus 1, still equal to 0, right? And so I can put my x squared minus 9 together and my x minus 1 together. Now remember, this is not factored completely. Solving by factoring, we want to factor completely. So this x squared minus 9, that's a difference of squares. So I can factor that further. So x minus 3, x plus 3. And the x minus 1 is still there. Remember that that only works for differences of squares. It does not work for sum of squares. So this is going to be each one set equal to 0 to actually solve it. And so I'm going to get x equals 3, x equals negative 3, and x equals 1. So 3 solutions there, right? All right, let's look at another one. Let's look at letter H. So here I'm factoring again, and I see that there's a GCF, and that's always what I should look for first. So minus 5x minus 14 equals 0. And I then see that this is further factorable. So I want what adds to be negative 5, multiplies to be negative 14. You could split the middle here if you wanted to, but this would give me negative 7 and plus 2. And so I'm going to set each part equal to 0. 2 will never equal 0, so that's not going to give me a solution. X minus 7 will equal 0 when x is 7, and x plus 2 will equal 0 when x is negative 2. So again, I have 2 solutions for that. And then the last one we're going to look at on these solving by factoring is there's no GCF here, and so I need to just split the middle. So a times c is 63. Factors of 63 that add to be 16, that would be, let's see, 9 and 7. So I'm going to keep my first term, keep my last term, and I'm going to split this up into plus 9x plus 7x, right? That's why it's called split the middle. Take out your GCF here, that leaves you with x plus 3, plus 7, that leaves you with x plus 3. And so this leaves me with 3x plus 7 times x plus 3 equals 0. So I set each of those equal to 0, so x equals negative 7 over 3, and x equals negative 3. So again, solving by factoring is different than just factoring. You need solutions. The other thing I would urge you to remember is solving by factoring, you need it to equal 0 first, because the zero product property only applies when it equals 0. Okay, let's keep going. So analyzing graphs, I actually think we're pretty strong at. I'm going to skip over that for right now because I don't think that's something we need a ton of practice on. Let's look at graphing these quadratics, stating the vertex and axis of symmetry. And two different things you need to do to be able to do this. So number one, to graph it, you can just put in your calculator. That totally works. But we are going to find vertex and axis of symmetry here. So this one's already in vertex form. So that means my vertex, remember if it's in parentheses, you're going to switch the sign. So -1 and then 4. And the axis of symmetry is going to be x equals -1. Remember that your vertex and your axis of symmetry are related to each other. And we can see that from the graph. So if we actually graph this, you could put it in your calculator, but this would have a vertex at -1, 4, and then these would be your other points. And I can just get those from the table, or I could plug in values. And I'm doing this on my phone, so I'm sorry, it's a little rough. But that's your basic shape. And remember that your axis of symmetry is going to go straight down through your vertex. So that's why it's x equals -1. Now, to find your vertex and your axis of symmetry, if you're not given it in vertex form, there's two different ways you could do it. So I'm going to do it both ways so we know the difference. The first way is to use the vertex formula, which remember is just the quadratic formula without the plus or minus and the radical, right? So -b/2a, which in our case would be +6/2. So that would tell me that my turning point's at 3. And to get the y value, you would find the y value at 3, which if you plug that in would be 0. So this tells me that my vertex is at 3, 0, and so my axis of symmetry is x equals 3. Now, you could also do completing the square to put this into vertex form, and we'll practice another one of these in a second. But the basic idea would be that you would add 9 to both sides, or I'm sorry, subtract 9 from both sides to get the squared part alone. Sorry, guys. Phone makes it hard. And then you're going to complete the square. So take half of this, that's -3. Square that, it's 9, and I'm going to add 9 to both sides. So here I would get g of x equals, and then the right side I'm going to factor. It's going to be x minus 3 squared. Remember, you can actually factor it, or you can look at this and say that variable, that number squared. And so this in vertex form would be g of x equals x minus 3 squared, and there's really a plus 0 there, right? So that tells me my vertex is at 3, 0, and my axis of symmetry is at 3. So on your graph, you could put your vertex at 3, 0, and then you could graph it using the points on your table. Okay, so finding vertex and axis of symmetry, we just did that with these. Let's talk a little bit more about that when we go to topic 4. So let's go there. So this says complete the square to write in vertex form. So if I wanted to find the vertex, again, by putting it in vertex form, I could subtract 5 from both sides. And then I'm going to complete the square. So half of this is -2. -2 squared is 4. So I'm going to add 4 to both sides. So I get y minus 1 equals, and then when I factor this, remember I'm going to do this variable, that number. You could also just factor it normally, but this will always work, x minus 2 squared. And so I wind up with y equals x minus 2 squared plus 1. And so again, that would give you your vertex is at 2, 1, and your axis of symmetry is at x equals 2. Okay. So remember, you can either complete the square or you can use vertex formula, but also remember completing the square is only going to work if your leading coefficient is a 1. So let's talk about inverses while we're here. Inverses should make you think of one key phrase. It should make you think switch x and y. That's the big thing to remember with inverses. So this is really y equals x squared minus 2. So when I switch x and y, it's going to be x equals y squared minus 2. And so I'm going to add 2 to both sides and then square root both sides. So y equals plus or minus the square root of x plus 2. I'm not going to switch this back to be f inverse because that's not a function. This would not be a function when you invert it. Wouldn't pass a vertical line test. And so I'm going to leave it as just y equals. Okay, let's talk about complex numbers because this is another thing we had some questions on. So remember when we talked about powers of I, we said it was a cycle of 4, right? So I to the 0, well, anything to the 0 is 1. I to the first, a number to the first is just itself. I squared equals -1 because remember I is the square root of -1. So if I square both sides, I just get -1. And then I cubed is -I. And then I to the 4th would be 1 again, right? It's this cycle of 4. So what I'm talking about when I do higher powers of I is I'm saying how far in this cycle would it go, right? So if I do I to the 4th, well, that's I to the 1st, 2nd, 3rd, or I'm sorry, 0, 1st, 2nd, 3rd. I to the 4th would land here again. I to the 5th would go 1 past. I to the 6th would go 2 past. I to the 7th would go 3 past, and then I to the 8th would be back there. So what I'm really looking at is how far past 4 is this going, right? How far past I to the 4th? And so I'm looking at the remainder when we divide by 4. So we're going to divide the exponent by 4, look at the remainder. If your remainder is 1, it's going to be equivalent to I to the 1st. If your remainder is 2, it's going to be equivalent to I to the 2nd, which is -1. If the remainder is 3, it's going to be equivalent to I to the 3rd, which is -I. And if the remainder is 0, it's going to be equivalent to I to the 0, which is 1. So let's simplify a couple radicals. Now the basics of simplifying radicals, remember, is that we're going to take a radical and we're going to say, okay, how could I rewrite that as a prime? So 18 is 3 times 3 times 2. I see a pair of 3s, so I'm going to take that out. And I don't see a pair of 2s, so that would look like 3 radical 2. So let's try it with this one. So square root of 7 is -1 times 7. Square root of -1 is I. The square root of 7, I don't know. It's just an irrational number. 7 is prime, so that's going to be I radical 7. But what happens when we go a little further? So like square root of -180, right? This is the square root of -1 times the square root of 180. The square root of -1 is I. And the square root of 180, well, let's write that out. So 180 is 18 times 10. 10 is 2 times 5. 18 is 2 times 9. And 9 is 3 times 3. So this is really the square root of 2 times 2 times 3 times 3 times 5. So I wind up with I've got a pair of 2s and a pair of 3s, so I can take that out. And the 5 would stay under there, so that would be 6I radical 5. Big idea here is whenever you have a negative under a radical, you're going to wind up with an imaginary answer. So let's do some of these powers of I. I'm just grabbing a calculator so I can divide these a little quicker. So for I to the 545th, I'm going to do 545 divided by 4 because I want to know how far around my cycle that would go. That comes out to be 136.25. And so that means it would go around the cycle 136 full times, and then it would go around another quarter of the time. And so think about your cycle. 1/4 of the way would be here. That would be a remainder of 1. So this is going to be equivalent to I to the 1st, and I to the 1st is just I. This works the same for 658. So if I do 658 divided by 4, I get 164.5. So this would go around our cycle 164 times and then go halfway around the cycle again, which is 1/4, 2/4. So this is the same as I squared, which is -1. Now if I do 452 divided by 4, that's going to be 113 even, which means your remainder is 0. So this would go around 113 times, and it would land back at the top of our cycle. This is equivalent to I to the 0, which is 1. Remember, for low powers of I, you can just put them in your calculator, but when you get to those high powers, you've got to divide it. So we can also do operations with powers of I. So like, let's say we have one like letter B. This is just multiplication, so I'm going to distribute that out. This would be 55I plus 30yi squared. We never want a power of I higher than 1. So this is going to be 55I plus 30y, and I squared is equivalent to -1. So this would really be -30y plus 55I. Whoops. Now let's look at one like e. So e, there's a couple different things you could do here, and I'll talk about it both ways. So first of all, order of operations, I see this is squared, and I'm going to need to square before I multiply the 3yi. So if I do I minus 4i squared, I'm going to multiply this out, and so that would give me I squared minus 4i squared minus 4i squared plus 16i squared. And I squared is -1, so this really just becomes, let's see, this would be 17 minus 8, so 9i squared, which would be -9. And then I'm going to multiply that by 3yi. And so this becomes -27yi. Now, another way to do this would be to say, oh my goodness, there are actually some like terms in those parentheses. So I could do 3yi times -3i squared, which would be 3yi, and then -3i squared is 9i squared, square each part. And that becomes, let's see, 3yi times -9, and that leads me to my same answer. So multiple ways to arrive at that answer, but just make sure you're cognizant of the fact that squaring means multiply by itself. All right, let's do a quadratic formula. So with quadratic formula, you will always be given this. Remember that hiding in there is your vertex formula, -b over 2a if you ever need it. But let's try one of these and make sure we got it. So here, a is 1, b is 6, c is -4. And I know that because this equals 0. We need it in standard form. So I'm going to do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be -6 plus or minus the square root of 36 plus 16, which is 52, all over 2. Now that's correct, but we're going to simplify this radical. So 52 is 2 times 26, which is 2 times 13. So I have a pair of 2's. So it's -6 plus or minus 2 radical 13 over 2. Now, everything here is all the numbers 6, 2, and 2. Remember, we're not going to go in the radical. Those are all divisible by 2. So I'm going to divide everything by 2. So it'd be -3 plus 1 radical 13 and -3 minus radical 13. And that would be my solutions. Let's do another one. Notice on the directions on these, it says answer in a plus bi form. That tells me that my answer is probably going to be imaginary. So here I've got a equals 1, b equals -8, c equals 25. Again, I know that because this equals 0. So x equals -b, which is +8, plus or minus the square root of b squared minus 4 times 1 times c, which is 25, all over 2a. So I wind up simplifying under the radical first with 8 plus or minus the square root of 64 minus 100, which is -36, all over 2, which is correct, but we need to simplify. So 8 plus or minus the square root of 36. Well, the square root of 36 is 6. Square root of -1 is I, all over 2. And I want to write this in a plus bi form, so I'm going to divide each of these by 2. So 4 plus or minus 3i. So it's 4 plus 3i and 4 minus 3i. All right, let's complete the square. And I highlighted a line on this because we need to remember that if the value of a is not 1, we need to factor it out or we need to divide it through. So we're going to do 2 of these. So here's the first one, x squared minus 12x plus 23 equals 0. I'm going to subtract 23 from both sides. And then I'm going to complete the square over here. So this is -6. Square that, it is 36. And whatever I do to one side, I do to the other. So that would give me x minus 6 squared equals 13. Now square root both sides, x minus 6 equals plus or minus square root of 13. And then add 6 to both sides. So x equals 6 plus or minus square root of 13. So I get x plus radical 13 or 6 plus radical 13 and 6 minus radical 13. All right, let's look at another one where it says a plus bi form. So let's actually not do that one. Let's find a more interesting one. Let's try this third one. So I get x squared plus 2x equals negative 20. The constant's already over there, so I'm just going to complete the square. And half of this would be 1, square that, it's 1. So I'm going to add 1 to both sides. So on the left side, it's going to be factored to be x plus 1 squared. Remember, that's always going to be this variable and that number. On the right side, I'm going to get negative 19. And now square root both sides. So x plus 1 equals plus or minus square root of negative 19. Now, I can't simplify the 19, but I can simplify the radical. So this is going to give me x plus 1 equals, I can take out the I and square root of 19. So I get x equals negative 1 plus or minus I radical 19. So my two solutions are negative 1 plus I radical 19 and negative 1 minus I radical 19. All right, systems, topic 7. This will be on a quiz after break. I want to spend a little bit more time on it, and nobody else is quizzing on it, so we're going to skip that. If you want to practice it, you can, but let's go to topic 8. So quadratic applications. The deal with applications is when you're looking at a parabola, you're going to look at two things. You're either going to be trying to find the vertex, and to do that, we're going to do negative b over 2a, or you can complete the square. Or you're going to be finding the zeros, which would tell you to either factor or use quadratic formula. So I'm going to look at, let's look at the second one. So the barber's profit each week depends on his charge. It's modeled by this equation. So the thing I would encourage you guys to do is think about like your input and your output. Your input here is the cost, the output is the profit, right? What price should he charge? So that's the cost. All right, how much should he charge? That's in cost to maximize his profit. So this is talking about a vertex, right? A maximum. So let's find our vertex here. So I would say our vertex will be when x equals negative b over 2a. And that would be x equals 6. Now, think about your vertex. That's your x coordinate. We don't know the y coordinate. In this case, it was asking us just for the cost, for the C value, right? That's your input. So here you could actually stop and say it should just be $6. Now, to figure out the Y value, if you needed it, you could plug that into the formula, right? Plug in 6, and that would give you out your Y value. That would give you your profit. But it didn't ask you for that here, so you didn't need it. All right, and then the last topic we talked about was focus and directrix. So we're gonna hit these really quickly. And the big thing I want you to remember with focus and directrix is the general formula. So if you have x minus h, y minus k, that's your general basic start. hk is your vertex. If you have x squared, that means it will open up or down. Remember, x is what you've always seen squared, right? You could put x squared into your calculator and that would open up or down. And then the coefficient over here will be 4p, where p is the distance from the vertex to the focus or the vertex to the directrix. The same thing flies if you have something open left or right, except in this case, y would be squared and your 4p would be next to the x. So let's look at one like this one. So I see x is squared, so this will either open up or down. And let's start with my vertex. So x plus 4, y minus 2. So my vertex is at negative 4, 2. And I know it's going to open up or down. Since this is negative, I know it's going to open down. So now let's figure out our p value. That coefficient is negative 8. So 4p is going to equal 8. P should be 2. So let's see where that puts us. So if I put my vertex at negative 4, 2, I know this opened down, so the focus would be down 2. So that would be negative 4, 0. And the directrix would be up 2, and you're going to draw a line. So that would be at y equals 4. So it would look something like that. Now the axis of symmetry is going to go through my vertex. It's going to be a vertical line through x equals 4. Or I'm sorry, negative 4. So that would be my vertex, or axis of symmetry. All All right, and then lastly, let's look at this one. I see y is squared, so this is either going to open left or right. And since this is positive, it's going to open to the right. So my vertex is going to be at -6, 1. And we know that 4 should equal 4p. So p equals 1. So let's see what we know. So -6, 1. It's going to open to the right, and p is 1. So my focus would be 1 to the right. My directrix would be 1 to the left. It's going to open that way. So this would be -5, 1. This would be x equals -7. And your axis of symmetry is weird on this one because it actually is going to be horizontal. So this will be y equals 1. So again, sketch it out, think about what direction it opens, and then go from there. All right, I know this was a little rushed, guys. I'm sorry. The live stream went a little slower, but again, I'm recording this on my phone in the middle of my planning period. So please send me questions as you study. You guys are going to rock this, and I will see you later.